Hello, and welcome to this webinar on performance, especially concerning Oracle Service Bus. My name is Mike Croft. I'm a member of the Managed Services team here at C2B2, and we offer independent middleware consultancy on some of the products that you can see there at the bottom, JBoss, Oracle, and VMware. There's a full list of things that we support and services that we provide on our website. I really would encourage you to visit that. That's c2b2.co.uk. But today we're going to be looking at part 4 of this SOA Suite 11G Performance webinar series. That's that one. So already we've looked at the principles of performance tuning, some JVM specific things, some WebLogic specific things. So today we're going to be looking at Oracle Service Bus specific things. And still to come, we've got some BPEL performance advice and SOA Suite performance advice. So what's this webinar actually about? OSB performance, it's not really a particularly descriptive title. It's quite a large area, so it could cover many things. So first, a quick recap, give you a bit of context from particularly to outline where we're coming from with this particular webinar. So week 1, Steve covered general principles of performance tuning, just guidelines, things to consider and bear in mind when you're beginning performance tuning. And that applies to Oracle middleware as well as any other sort of middleware or IT project. In the second week, we saw Matt give us a few examples of Java-specific tools that come free with the JVM, things that help you diagnose and monitor what your JVM is doing, help you decide how to adjust GC settings, heap sizes, that sort of thing. And last week I spoke about WebLogic specific tools, things that help you diagnose things and make decisions and things to tune in WebLogic to give you optimal performance depending on your business needs. So about this week, well, this week our agenda is as follows. We're going to be looking at designing services for performance. Now obviously a lot of the tuning advice, which I will be touching at towards the end of the webinar, there is a lot of crossover with Oracle WebLogic. Obviously Oracle Service Bus does run on WebLogic, so there is a lot of crossover there, so I won't spend much time on that. If you do want to find out more about areas to tune, I would really recommend that you check out the webinar that we did last week. That'll be up on YouTube imminently. But aside from that, we're going to be looking at best practices and you might want to call those golden rules for OSB and for how to go about developing in OSB. Now you might notice I've put best practices in quote marks there. That's not a mistake. That's something that I hear Steve, my boss, say quite often, is that the phrase best practices when it comes to this sort of middleware is really a bit of a misnomer. It's irrelevant. There's no real best practice that's universal. All best practices depend on how you're using the product. What are your goals? What do you want to get out of it? Obviously there's no use configuring your environment to give you absolute maximum throughput when that compromises your reliability. If you're a financial institution, you really have these reliability constraints. So certainly, speed at a cost of reliability in that sort of situation is really not where you want to go. So best practices, but still keeping in mind your own use cases. So here's a diagram that you've seen before, if you've seen some of the other webinars that we've done. This is just an outline of the tuning process. So this is coming at a view of your design of your applications and your services have been completed. all your infrastructure is in place, and you want to adjust things, tweak things, give yourself the best possible advantage with what you've already got. Now that is still very relevant with what we're going to be talking about today, particularly that process, the way that we do things, in that we use measurement and analysis to give us data through which we get our hypothesis. We don't make a hypothesis just based on feelings. The change step, make one change at a time, then test and then gather more data and see how things have improved or what other things have been affected by the change. That does still apply when you're talking about design. But when you are thinking about how to design for performance, you're starting right at the beginning of the project. You're thinking about how can I construct my OSB service or composite my existing OSB services in such a way that I can reduce latency, or that I can reduce the amount of CPU overhead or network hops. So that's what we're going to be looking at, is designing for performance. And the first thing you want to think about is what aspects of OSB do we need to consider when we're thinking about performance. I've outlined 4 areas I think are particularly important in OSB, and it is certainly important to understand these factors and how they influence performance from an OSB perspective before you start tweaking things or adjusting things. This will help us, or hopefully help you, in understanding better your use cases and the sort of areas where you might want to concentrate on finding performance gains. So the first is message size. Now message size is very much about finding the sweet spot for your use case. You might want very small message sizes so that you can get a really big throughput. Obviously throughput does fall with increasing message size, but then there are various different optimizations in OSB that you can use to mitigate that. For example, there's content streaming, which we'll be looking at a little bit later, which enables a sort of partial parsing mode of XML data. You want to consider the message flow for each of your services. So just as an example, XML processing is going to be much more expensive in terms of CPU overhead when you compare it to core OSB performance. The OSB runtime's very highly optimized. XML processing is not as fast. So the numbers of different sort of transformations that you're doing between these different data types has an impact. The amount of time it spends in one data type, if you are only doing an XML transform or XML-based routing on in one part of the flow, it might be worth thinking about how you can readjust that so that you can avoid using XML if the rest of your service doesn't use it. Network, it's important to understand the underlying transport and the sort of performance characteristics that derive from the transports that are used. So, for example, HTTP and JMS have very different characteristics, different sorts of quality of service, different message envelopes, for instance. This is all things that can be taken into account when, even coupled with message size, for instance. And lastly, reliability requirements. As I mentioned before with the example of the financial institution, sometimes you might find that your performance gains come at the cost of something. Often, if you have a big reliability requirement, you're going to have to sacrifice some sort of speed. Now, this may come with Yeah, sorry. The speed improvement might come with a reduction in reliability, and you need to decide how important that reliability is for you and whether it's critical to your business. So let's get into some best practices. Now, I've tried to arrange these and group these together in such a way that they make sense and the same things are grouped together a little bit. So let's start with the first one, message routing. Now, obviously, with any ESB, the focus is on messages, and a big part of ESB activity is message routing. And particularly with OSB, it's always good to place any routing information that you can in the transport header. So, for example, the SOAP header, and make your decisions based on that. And that's because the parsing of the SOAP headers happens, and any transport header happens independently of parsing of the message body. So obviously your transport header is a known quantity. You know how big that is, and you know how long it's going to take to parse that, and it's not really going to change much between different messages. Now the message body, that's going to change quite dramatically depending on your use cases. But the message body could be very, very large for certain things, or it could be very, very variable. So some might be large, some might be small. And this is introducing a level of unknowns into your application performance, and it's also meaning that you're having to do double the work because the header gets parsed and the body gets parsed. It's much better to just exclude the body being parsed and just parse the header. Secondly, EJB communication. Now, EJB communication is sort of designed with the idea in mind that it's going to provide loose coupling, which is a very good way of designing your applications. It allows for good reuse of services, but that loose coupling does incur an overhead. Certainly the fact that it's EJB is designed as a message-oriented interface with WSDL as a description language. These interactions were designed to go through just a standard JAX RPC binding, but that binding obviously has a cost in terms of transformation and translation, which is, it's okay if your main goal is to have reusable services. That's perfectly fine. But if that's not really a particular goal of yours, you're not really interested in the loose coupling that would provide, just using a simple Java callout might be a better solution to doing these JAX RPC calls, which would be more tightly coupled, but it is a lower overhead. So next we've got this streaming that I mentioned earlier. Now, enabling streaming, really you're getting the best advantage from streaming when you're doing content-based routing. So you're not routing based on your headers, you're routing based on your message bodies. And what streaming does is it will only partially parse the message. It will use the XQuery engine to just parse what's needed rather than the entire message. So you will notice big gains with very large message sizes. The larger the message size, the bigger the gain. That doesn't mean to say that you should absolutely go away and have very large messages with streaming enabled. It does give you very large gains, but it's very large gains relative to large messages without streaming. So in this next slide, I'm going to be using this sort of example template XML document, and I'm going to go over some XPath and XQuery tuning and design considerations. So firstly, always avoid double slashes if you can. Sometimes at design time you're not going to know the exact XPath expression to find a particular value. In this case, we've got $body / postcode, and that's obviously going to come down here and find this postcode element here. And it's always better in terms of expense, CPU expense that is, to address body, order, address, postcode. So if you can put the full path in there, absolutely do. It will definitely give you some advantage. But you can also index the XPaths. Now this will give you another advantage on top of what I've just said. So now you can see that we've got this $body / order, but we've got this bracket 1, which is very similar and is used in a similar way to an array index. Now you can see that the number 1 is in there. That's because the array index starts at 1. Doesn't start at 0. If you put 0, it won't work. So in this case, we've only got one order element. Now, what your XQuery engine will do, if you don't include that array index, it will look at body and order and think, well, I need to find every instance of order. So it will look at your first order tag, and it will say, okay, there's one, and it will pass down and pass down and pass down until it's reached the bottom of your XML document, and there's no more order elements, and then it will just take that one that you've got. Now when you specify the 1, it will get down to your first order element and then stop. It won't pass any more because it will think, oh, you only want the first one, and stop. And if you know that there's only one element, then that's absolutely fine. That's exactly what you want it to do. So you, especially with a large message size, again, this is stopping you from parsing the entire message tree when you don't want or need to. Now it is important to note at this point that indexing should not be used when the expected return value is an array of nodes. So for example here, if I'd got $body / order bracket 1 / items / item bracket 1, that would only give me the first item. And if I wanted all of these items, then I would be missing all the rest of the other items, and it's quite a nasty little thing to track down once you've written it into your code. So that's a very important thing to remember. It will obviously only return the first in an array. If the array is 1, then you only want the first one. But if you've got a lot of nodes, then don't use it. Another best practice is to use intermediate variables for commonly accessed parts of your XML document. Now you can see I've got let $items equal body / order 1 / items 1. Now here again I've got just one order element and just one items element, and it might be a frequently accessed element, that list of items. So I've used this let, which is a flower expression, if you're familiar with your XML language. Now this intermediate variable can be used to store items, in this case, as a common context for multiple values. And it also can be used, or it's advised to be used instead of context variables, which we'll see in a minute as well. And lastly for this slide, it's always a good idea during the message flow through your pipeline to minimize data type conversions where possible. So if you are doing an assign action, for instance, that's going to return you an XML bean, then then it's going to be a good idea to return an XML bean from a Java callout rather than returning a string. It means that the conversion is not happening within OSB, and it's some other excess work that you don't want OSB to be doing that you can avoid quite easily there. So just as I've mentioned, it's a good idea to avoid creating context variables unless it's actually wanted. Now, context variables which are created using an assign action, as I've said, are converted to XML beans, and then they're reverted to the native XQuery format for the next XQuery. So they begin in the XQuery format, they're converted to an XML bean, and then if you need to do any other XQuery operation on them, they have to be converted back. So that's a double overhead cost that you've got there. So do try and collapse these multiple assign actions that some of you may have into a single assign action, and you can do that using a flower expression again. You can use intermediate values instead, because obviously I've just said it can increase data type conversions, but it's not the worst thing in the world using context variables. They do have their place, and they are very useful alongside this content streaming, which can be enabled in OSB. Just to go over that once more, streaming is a way of only partially parsing the message body, only parses what you need to read. Now the gains from streaming can be negated if the payload is going to be accessed a large number of times for reading multiple fields. Now, if all of the fields that are going to be read are located in a single subsection of this XML document, a hybrid approach is going to provide the best performance, which is going to be using these context variables as well as streaming. So instead of streaming with the entire document, you can use a context variable to take part of the document, and again you're just reducing the amount of work that OSB has to do, making the document artificially smaller, if you like. And as I've said, the assign variable, the assign action can be a little bit expensive, so it's better to use replace to transform the contents of a context variable. For instance, the $body. So if you know that you're going to replace the entire body, it's much better to use the replace action, since the assign action actually uses an XPath expression. So in the previous example, $body/order, that would take the entire body contents. It's much easier to leave the XPath field blank and then just select replace entire node rather than replacing the node contents. What that means is that you're eliminating this extra XQuery evaluation. And again, I've said it before, I'll say it again, it's eliminating extra work that OSB doesn't need to do. Now this expression here, $body/*1, now you might be able to work out what this does, but OSB can actually detect that as a special XPath. So not only are you getting the gains that I've mentioned before about using the index of 1 to get the root element of your body, it will detect that it's $*1 and treat it as a special XPath that can be evaluated without invoking the XQuery engine. So although it is XPath, it's not going through XQuery. Now this is much faster than specifying an absolute path, pointing to the child element of body. So a general XPath like body/order, that's going to have to be evaluated, but this one isn't. Next, you want to set the appropriate quality of service level and transaction settings. It's always best to avoid XA where it's possible. As I mentioned before, due to reliability or security constraints, that might not be a possibility for your business. You're going to need XA or a two-phase commit protocol. But there is a way around that. Obviously, XA is expensive because it's got these multiple phases, but you can also use last logging resource, or you might see that written down as LLR, and that will achieve the same level of reliability if OSB initiates the transaction. Now, OSB can invoke a back-end HTTP service asynchronously if the quality of service is best effort, and asynchronous invocation allows OSB to scale better with long-running back-end services. It also allows publish over HTTP to be a true fire and forget mechanism. So just moving on to a little word about tuning. A lot of this obviously I've covered already in the WebLogic webinar, so I won't spend much time on it. But it is quite critical to identify where tuning is appropriate, because, as I've said, it is a trade-off between speed and usually something else like reliability or security. Now, a good principle to bear in mind is that you don't want to reinvent the wheel. Oracle MIddleware has provided services that you can use over your own code, which is almost always a better option. So, for example, rather than connecting to a remote JMS queue, you might want to bridge it. And the JMS bridge provided by WebLogic will be more performant, more reliable, more secure, so that there's no need to reinvent the wheel, because it's already been, well, I won't say perfected, but they've got it down pretty well. So a good thing to consider is architecture. A basic architecture is preferable because you're reducing the amount of network hops over multi-tier. But obviously you can't do a basic architecture if you share objects across applications, or if you need load balancing between the presentation tier and the object tier. Now for JDBC, along with a lot of other things, when you've got an initial capacity and a maximum capacity, it's always good to set those to be the same value where possible, so that you're not having this overhead of increasing the number of connections. And particularly with JDBC, there is a statement cache that you can use, which improves performance of pre-prepared or callable statements, and an inactive connection timeout to use, which will detect inactive connections and return them to the pool. So that'll free up some resources for other processes which need them. JMS has a few different capabilities in OSB and WebLogic, which allows you to perform load balancing and spread the workload out with things like the uniform distributed queue capability, and obviously you'd need to disable server affinity with that, so you can enable the producer to load balance across multiple destinations. If you find that memory is an issue, you can configure memory paging, and it's always good to remember that if you don't need the persistence, do explicitly turn that off, because that's something that can be on without you knowing it for quite some time. Work managers, make sure that minimum thread and maximum thread constraints are the same reasons as JDBC connection pools there. And coherence, that's a very large area to cover, but caches can vastly reduce latency on frequently accessed data. Now in WebLogic that might be HTTP session caching, but but in OSB there are a few specific areas where making use of a cache and specifically coherence can give you great benefits. So let's look at cache tuning. I've got two examples to tell you about here. The first is the router runtime cache. Now, if you don't know what this is, it's the cache which caches newly created proxy services. So on the first time that a proxy service is called, OSB creates an instance of it and it will dump it in the router runtime cache, and it will stay there to be reused for each subsequent message. So for the first time that you invoke any particular service, you'll get a little bit of overhead of having to create it, but other times that gets accessed, you won't have that same overhead because it's already there, it's already created in memory. Now it has two sections, static and dynamic, where proxy services in the static section are not garbage collected, but those in the dynamic section are. Now the default size of the static section of the cache is 100 entries or pipelines. So if there are fewer than 100 proxy services to be cached, there's no problem. But when that goes above 100, performance will begin to degrade as the likelihood of some frequently used services not being permanently cached starts to rise. And you can set that property with the in the setDomainEnv.sh file as an extra Java argument, just like that. And that's just that size value there is just a number. So by default it's 100. You can make that larger or smaller depending on your needs. Next is the service result cache. Now this is where OSB uses coherence. So using the service result cache, it's basically a simple way to mitigate a problem service which gives you a bottleneck in any particular scenario. It can vastly reduce problems that are caused by network latency or any other sort of unreliable connection or maybe a slowdown from the external service. Now it makes response times very fast since the result is going to be already there on the second call. So once it gets the response back, it will cache that response and then won't do the jump to the external service the next time. So you can see on the diagram, the first time through it'll go to the external service, but then it will store that in the cache, and on subsequent calls it will just go straight to the cache and not go to this service anymore. So obviously that result doesn't need to be fetched or calculated, but that does mean that the response might be stale. So you will need to configure a time to live there, which is the what TTL stands for, if you're wondering. So simply enabling the caching capability is going to give you a better throughput, and it's going to allow for a bigger volume of users and scale better. But this is still what's called an in-process caching strategy, which means it's going to still use the same JVM for caching as it is providing the OSB services. So your JVM is going to be having to juggle another thing, so it's going to have to cope with your OSB service and your cache. So now the solution to that problem, which isn't a huge problem, depends on your resource configuration, but the solution would be to use an external coherence server and enable that to cache the requests. And just as a quote from Oracle, they say, out-of-process caching can drastically reduce the JVM memory footprint of an Oracle Service Bus domain and increase the scalability and failover of the architecture, and it is a recommended approach for projects that need to scale safely. And that word safely there, you might have picked up on it, is referring to out-of-memory errors. So scaling in this way with an external coherence server avoids putting that extra strain on the heap. So just finally then, a quick word about logging, monitoring and tracing. It's quite an obvious thing to be commenting on, but it does still need to be said. It is very important that you run with absolutely the minimum necessary logging in any production instance. It should be set to the lowest acceptable level, so just error or warning where possible. And also HTTP access logging should be off if possible, because that is enabled by default. So if you're unsure whether that's on or not, do check. Next, good advice is to monitor anything with a critical SLA, critical service level agreement. Performance diagnostics and improvements always concerns things like a slowdown of service, or maybe a server going down for an out-of-memory error, and so breaking potentially an SLA. Monitoring a live system gives you the data that you can use to then, as I said right at the top, to make these sort of configuration changes that you need. It's always very important to make changes based on data. So certainly monitor the critical SLAs, but this is a minimum. Ideally you want to monitor as much as you can. More data is always better. And finally, tracing in production. Again, you might wonder why I'm saying it, but it does need to be said. Tracing in production is absolutely a last resort, and most people wouldn't even consider putting tracing on. Although it is possible with OSB to set trace without shutting down the server, so you have no downtime, and it can also be set on a per service basis. So now with that level of granularity, you can potentially run it in production. Obviously you want to do that with extreme caution. It's going to introduce a lot of overhead, but if you're absolutely at your wit's end with a problem, you've tried everything else, and you just want to quickly turn tracing on and off to give you an indication of where the message goes in the flow, what happens to it, how it changes, and any problem that happens to it, that can be achieved with OSB without affecting other services too much. And finally, domain mode. Do make sure that you run in production mode rather than development mode. It's not just for security or reliability reasons. It is that it's simply more performant. Also, if you've got a QA environment that you want to run performance benchmarks in, you need to make sure again that that's also in production mode so that you get accurate results. It's no good making your decisions based on data when that data is potentially inaccurate. So in summary, know your priorities, understand your use cases, make sure you know what your performance gains might come at the expense of, if they do, and whether or not that's acceptable to you. Maximizing performance is a process. You do need to make a single change, measure, test, see how it's changed, see how it's affected other things, then again make a change, measure, test. Always making a change backed up with data. I really can't stress that enough. It's not a good idea to just make changes without something to back that up. So thank you for listening. It's been a little bit of a long one, longer than I thought. But do please join us again next Monday when we're going to be talking about BPEL performance best practices. I hope you got everything out of this that you wanted to. If there are things that you wanted to ask or query about, please do make a comment on this video, which will appear on our YouTube channel, which is C2B2 Consulting if you search that on YouTube. And I hope to see you again soon. Thanks for listening.